Good morning, class 11. Let's continue. Today I'll be doing electronegativity. It's one of the periodic property. Okay. So let's define it. Electronegativity, it is the tendency of an atom to attract shared pair of electrons towards itself. It's the tendency to attract shared pair of electrons. Shared pair or bond pair, both are correct. Shared pair of electrons towards itself in a covalent bond. Because we know in a covalent bond, the bond is formed by sharing. So that's what the definition of electronegativity represents, right? So it is basically the attraction power. It is the attracting power of an atom for electrons. Okay. Now what are the factors of electronegativity? First factor, the common factor, that is your atomic size, nuclear charge. So we'll speak about them first. Atomic size. So if the atomic size increases, the distance between the nucleus and the outermost electron will increase. So what will happen? The nuclear attraction on the outermost shell or on the outermost electron will be lesser. So since the attraction is lesser, so the electronegativity will be lesser. So higher the atomic size, lower will be the electronegativity value. Because with increase in the atomic size, the distance between the nucleus and the electron increases. So what happens? The attraction power decreases, so electronegativity decreases. Now when I come to nuclear charge, with increase in nuclear charge, what happens? When the nuclear charge increases, the nuclear pull on the outermost electron or on the outermost shell increases. As a result, attraction is increasing, so my electronegativity will increase. So it is directly proportional to the nuclear charge and inversely proportional to the atomic size. Now we have some new factors, that is oxidation state of the atom. Oxidation state of atom. Now oxidation state is actually the valency of an atom with sign, either positive sign or negative sign. Now if an atom is in positive oxidation state, then its electronegativity value shows an increase. That is, for example, if I take Fe3 positive and Fe2 positive. So with increase in positive oxidation state of an atom, that indicates that particular atom or the ion is electron deficient, right? So it will have more electron attracting power. As a result, electronegativity will increase. Here you see Fe3 plus has more positive oxidation state than Fe2 plus, right? So it will be more electron deficient, so it will attract the electron strongly. So its electronegativity will be much more than the electronegativity of Fe2 plus. Now if I compare of negative oxidation state, suppose if I compare about O2 negative and N3 negative. Now if the negative oxidation state increases, in that case it is the reverse. Then the electron attracting power will be decreasing. Like this one has more negative charge compared to O2 negative. So N3 negative will be possessing less electron attracting power than O2 negative. So the electronegativity order in these two cases will be O2 negative greater than N3 negative. So as the positive oxidation state increases, your electronegativity increases. As the negative oxidation state increases, electronegativity decreases. Right? The next one we have participation of s orbitals in hybridization. Now we know that s orbitals, they have maximum probability to be found closer to the nucleus, right? So if s orbital is involved in bonding or in hybridization, that will increase the electronegativity of that given molecule or the given compound. So if I take examples of your organic compounds, this is my methane, this is C2H4, this is your ethene, and this is my C2H2, this is your ethyne or acetylene. Now this methane is sp3 hybridized, ethene C2H4 is sp2 hybridized, C2H2 it is sp hybridized. Now what happens? This sp3 hybridization, s character is how much? S character means your s orbital contribution. It has 25% s character, sp2 has 33% s character, sp has 50% s character. So So we see from sp3 to sp the percentage of s character increases. So if the percentage of s character increases, in that case your s orbital contribution is increasing, so my electronegativity will be increasing. That means s character is directly proportional to the electronegativity of the molecule. So the electronegativity order will be what? This one, C2H2 greater than C2H4 greater than your CH4. Now, which is the order of electronegativity? That will only be the order of the acidity of the compound. If I talk about acidity, what is acidity? Acidity means it is a tendency of a compound or of a molecule to liberate H plus ion. Now, since your S character is more, right? So, if S character is more electronegativity is more. So, the pulling effect will be more. As a result, your H plus will be easily liberated in case of C2H2, then C2H4, then CH4, right? So electronegativity is proportional, directly proportional to the S character, which is directly proportional to the acidity of the molecule. So acidity order will be also this one. Okay, right? Next one we have effect of the substituents. Effect of substituents. Substituent means the groups actually. I'll just explain by an example. If I take groups like CF3, then your CCl3, then your CH3. These are my groups. Now what happens due to the presence of electronegative group? Now this F, if I talk about the electronegative order of F, Cl and H, F will have maximum electronegativity because it has minimum size and maximum nuclear charge compared to Cl and hydrogen. So this is the electronegativity order of the substituents. So as the electronegativity order increases, then this particular group, due to 3 fluorine atoms, it will act as an electron withdrawing group. This will act as an electron withdrawing group compared to the other 2 groups. So due to the presence of electronegative atom, this CF3 group acts as electron withdrawing group. Now, so if I give you a compound CF3 COOH, Cl3 COOH, CH3 COOH, and if I tell you that which one is a stronger acid, just compare the acidity order. So we know that this group, CF3 group, is highly electron withdrawing group. So it will pull the electron and help in the liberation of H plus faster compared to these 2 compounds, right? So this will be my acidity order. This acidity order is proportional to the electronegativity order. It has maximum electronegativity, that's why it's electron withdrawing. It is acting as an electron withdrawing. Actually, it is due to the electronegativity of this fluorine atom only makes CF3 to act as electron withdrawing group. So that's what here I wanted to explain. And if I take another example, where we are talking only about the substituent, like CH3Br, then CH3Cl, then if I say CH3F. So here we know what is the order of electronegativity. F greater than Cl greater than Br. So we know higher the electronegativity, higher will be the electron attracting power. As a result, F will attract the electron more strongly in this covalent bond. Cl will attract, Cl attracting power will be lesser than F but more than Br. So if I compare the polarity order, if I talk about the polarity, then what will happen? This will be my polarity order. This compound will be more polar than CH3Cl and this will be more polar than CH3Br. So on the basis of substituents, we can compare the acidity and polarity of the given compound, right? So that only I wanted to explain over here. So these are the factors of electronegativity. Now we'll talk about the periodic variation, periodic trends. On moving down a group, what happens? Down a group and across a period. Down a group, across a period. Now, on moving down a group, the atomic size also increases, nuclear charge also increases, but the effect of increase in atomic size predominates, right? So what happens? The nuclear attraction is lesser. Now, as the attraction is lesser, electronegativity will be decreasing. So down a group, electronegativity, it's a downward arrow, that means it decreases. Across the period, atomic size decreases, nuclear charge increases, so the nuclear attraction increases. As a result, your electronegativity increases. Right? So this is the periodic variation of electronegativity. Now, let's speak about valency. It is another property, another periodic property. Yes, just like your electronegativity, ionization enthalpy, electron gain enthalpy, it is also periodic property, valency. Valency, though, we know that it is a combining capacity of an element. Now, if you follow the periodic table, we'll find out that what happens on moving across a period, that is whether the valency increases or decreases, and what happens on moving down a group. Right? So, we'll talk about the periodic variation or periodic trend. Periodic trend. Down a group, across a period. Now, you need to remember this. If you follow a group, on moving down a group, what happens? Its group number remains constant and valency also remains the same on moving down a group. Suppose if I take the example of group 1. If I move from lithium to sodium, my valency of lithium is also 1, sodium valency is also 1, because both lithium and sodium or potassium or any group 1 element will be having only one valence electron. So that valence electron is equal to the valency. Right? So basically on moving down a group, the valency remains fixed. The valency remains constant. It does not change on moving down a group. Whatever group we consider, whether it be your group 1, whether it be group 2, right, group 13, 14, right. In case of group 13, 14, we can have some elements which shows variable valency. Like for example, sulfur shows variable valency, then phosphorus shows variable valency. That's a kind of exception. But usually on moving down a group, the valency remains same. Okay. On moving across a period, what happens? Across a period, let's check what happens if I consider the second period. Second period if I consider, or rather generally if I consider, this is my group 1, this is group 2, then I have the group 13, because we'll only speak about the representative element, group 14, 15, 16, 17, 18. Now for group 1, we know the valency is equal to the number of valence electron. So valency is 1. For group 2 also, valency equals to the number of valence electron. So it is 2. 13 also it is equal to the number of valence electrons. So what is the number of valence electron here? It is your 3. 14 it is 4. Now after 14 what happens? The valency is given as 8 minus the number of valence electrons. 8 minus number of valence electrons. For 15 to 18 we will find out the valency like this. This is what? This is the valency. Till 14 valence is equal to the number of valence electrons. Right? From 15 to 18 valence is equal to 8 minus number of valence electrons. So in case of 15, what is my valence electron number? It is your 5. So 8 minus 5, for 15 the valency will be 3. 16 it will be your 8 minus 6, so it will be 2. 17 valence electron 7, so 8 minus 7 is 1, and 18 the valency will be 0. So what happens on moving across a period? What do we see? The valency first increases till group 14 and then the valency decreases. Okay, so this is a periodic trend of valency. So that's it, class. Thank you.